Okay, back again for episode number 19. Last episode was a bit chopped up because I had intended on introducing vacuum bagging back then when I was discussing what was going to happen with the empennage, the horizontal and vertical stabilizers that are going to have to be covered before we can advance anything on the fuselage, at least the fuselage that I'm going to cover in fiberglass. But then I started thinking it didn't make a lot of sense to break that up into two vacuum bagging parts, because we're also going to cut and vacuum bag the wing for one of these models. The other model will be covered with the paper glue or paper adhesive, the adhesive that I'm probably going to use is Mod Podge, but the other one is going to be done the other way, just to compare weights. So, since it didn't make any sense to just go into bagging portions of the tail and then have to revisit bagging again to do the wing, what we're going to do this time is we're going to set the tail parts aside for just a moment, and we're going to cut our foam core wings, and we'll go over it step by step, from blocking out the foam to using a drop wire, hot wire cutter. This episode might drag out a bit since I'm trying to make this completely comprehensible to a rank beginner with foam. So stick with me, and maybe you'll pick up, even you guys that know how to do this, maybe you'll pick up a trick or two along the way. But this episode, hot wire cut wings and vacuum bagging. Thanks for being here. Okay, the first step in cutting out the wings, or wing cores, is to cut out or block out the foam to the shape of the panel that you're going to be cutting. That's very easy to do if you have already printed out your template. These templates are what makes building these models so fast, and again, watching this series has not been fast, but once these templates are done, you can knock out one of these models over a weekend. It really is fast. So I've got the template on a rough cut foam. I'll use some of these little weights that I cast, and in order to save the foam, or at least cut down on waste, again, a fine tip Sharpie. Is all you need. And then for the next panel, just turn this upside down like this and align it with the other side. Okay, now you see it shares an edge, so one cut will separate the two, and that saves a lot of foam. This cut here with a wedge, by the way, these little wedges come in handy. You can prop up things or use it to prop up panels for dihedral or whatever you like. But I generate a lot of foam cutoffs, some of which are useful, some of which go in the trash. But here we are. Now, using the template, all right, I've got both outlined on this piece of foam. So I'll use my drop wire cutter now, do all the straight line cuts, and we'll have the two blanks for the wing cores cut out. Okay, when you're done blocking out the basic outlines of your wing cores, you'll end up with something that looks like this. Now we will take this. There is no right or left yet. The right or left part will come as how and how we assemble them later. But always keep in mind you're going to have a right and a left wing. I can't tell you how many times I've made two rights or two lefts, but that mistake will come later when we attach the templates to the cores in order to cut these out. But we'll be mindful of that when that time comes. In order to cut wing cores, the first thing that you're going to need, other than foam of course, is a set of templates. And there's a couple of ways. We've discussed templates briefly earlier. There are several ways and several materials that can be used. Here's one. I'll just show you right quick. If you have access to a 3D printer, these are 3D printed. Now on my Annette A8, the length of this thing was too large to fit the bed. So if you see here, it's got a little fishtail mouth there, a little V-cut. They were printed in two halves and then super glued together the same way for the lower one. This is the templates for the tip. They printed all as one unit on the Annette A8. Haven't cleaned them up yet, but there you go. The other alternative, if you don't have a 3D printer, which a lot of people don't, if you don't have a 3D printer, let me get it out of the way here, is a product called, my favorite, now there's other ways to do it of course, but my favorite is a product called phenolic resin board, and the best size and the easiest to handle is a sheet that's 0.031. That's about as thin as I can readily find it. It's even available on Amazon. 0.031 sheets. And what you do, of course, is print out the template, and I've attached this. You can see how thin this sheet is. It's extremely thin stuff. Okay, I attached the template printout to the phenolic board with Yoo-Hoo permanent glue stick. I love Yoo-Hoo stuff. It just works. I love Yoo-Hoo Pour for foam adhesives, and I love this stuff. It just works. I use a ton of this when I do stick and tissue model airplanes too. It's great for attaching tissue and stick and tissue models. But what I'm going to do is move the camera in where you can get a better idea of what's going on. I've just stuck this down. This is the lower template for the tip. I've just stuck this down. So I'll bring the camera in. I'll quit talking until we're done, and I can narrate the video later. But I'll bring this in so you can see the cuts. This stuff is easy to work with. This is paper. There are different kinds of phenolic resin sheets. This one is paper. They also have linen and canvas and some really heavy stuff. But you don't want that because it's hard to handle, it's hard to cut. You're going to have table saws or some pretty heavy-duty stuff to cut some of it, some of that linen laminated stuff. But this is paper laminate. Like I said, it's available on Amazon. I think it's about 11 or 12 bucks a sheet, delivered to your door. So, and this is, they advertise it as a 12 by 24, and they lied. It's not 12 by 24. It's 11 3/4 by 23 3/4, but that's Amazon for you. So let me bring you in closer so you can see what's going on, and then we'll go from here to the scroll saw, because you can't cut this stuff out unless you've got a scroll saw or you're good with a coping saw. And you want to do it that way. But I'm telling you straight up, an inexpensive jigsaw from Harbor Freight will save you tons, and it's awfully useful to have around the shop. So this is 3D printing. This is a set already done, 3D printed. The other alternative is aluminum flashing. You can use aluminum flashing for templates too. I just prefer this stuff. So here's how to do it. Okay, these phenolic resin templates have been cut now, and of course they came off of the saw rough. So they're going to have to be sanded, which is one reason why I like to 3D print mine now, because you don't have to do that anymore. You do have to put, I'll have to show you that later too, some aluminum tape over the top of those 3D printed ones. Cut about a half-inch wide strip of aluminum tape and tape it down over the top, because even the high temperature printing filament won't take the kind of heat that's going to be required here, and you'll end up with a lot accurate. Take your time cutting these, because your wing is going to be what you cut here. What you cut here is going to be reproduced in foam. So if you get it right, you're going to have an accurate airfoil. If you mess it up, you're not. But these sizes, it's not rocket science. The other thing is, or the last thing I should say is, if you'll notice these holes that we put when we drew the things in CAD, they're exactly aligned, so that when you drill these holes, I like to line them up like that and drill through both at the same time. That way the holes are in exactly the same place, because you're going to have to put the lower template on, cut through the foam block, then pull this out and put the upper on and cut it through the block. So you need these holes to be accurate. I use finishing nails to hold these into the foam block. We'll get to that in just a moment. There's two sets of templates, and you can make templates out of almost anything. Like I said, aluminum flashing works, 3D printing works, phenolic resin works. Formica, if you can get some Formica cutoffs from a cabinet shop, Formica works. I would add one thing though: when you're cutting with a jigsaw on this thin 0.031 inch resin board, make sure you use a high tooth count blade. I wouldn't use anything coarser than about a 24 or 25 tooth per inch blade, and the higher the better, and the smoother the cut you'll have. Okay, time to actually cut some foam wings. Before I do that, well actually I'm going to do that right now, but I'll show you my drop wire cutter. It's very easy to build. It was put together with stuff from Home Depot. Anybody can do it. It's just dead simple and easy. So let me show you my drop wire cutter. Then we're going to do a simple constant chord wing, not the wing for the zero, but a simple constant chord wing to show you how it works basically. Then we'll go on and do the chords for the zero, which will be of course tapered chords and require just a bit different setup. Okay, well here's the machine. Okay everyone, we'll do a quick walkthrough of my actual drop wire setup. It is dead simple, very easy to make, and you can get all the components real cheap at big box stores like Home Depot. I got this stuff from Home Depot. Let's start over here at the pivot end, and we'll go right down here. Excuse the mess, there's a lot of distractions here. The crossbar that's attached to the bench is 1 inch by 1 inch aluminum angle. The drop bar is 1 inch by 1/4 inch aluminum bar. Now you can see here the pivot is simply a bracket with a bolt through it. Now the bulldog clips, they come later for attaching the wire to the drop bar when we use the thing. Now going out this way, you start to see the turn points. I had some pulleys. These are very large pulleys. You don't need them that large. I just happen to have these in my 30-year box, so I use the things. The pulleys can also, or most people use pulleys, again from the big box store, and as pulleys they use the rollers for sliding glass doors. Just get some replacement rollers for sliding glass doors. Okay, moving on along out this way, that is the turn pulley for the left-hand side of the drop bar. This is just a feeder that helps hold the line up, and here's the turn pulley for the right-hand side of the drop bar. Going out here, there's a spare block that I made. It's just sitting there, and then on the far end you can see the pulleys that change the rotation and take the wire down to the drop bar itself. And that's what this one here does too. It can take the wire down as well as just supporting one across the whole span. Again, moving out here to the very end, this, whoops, that was me knocking over my tripod. But out here, this end just lifts off. That bulldog clip keeps it from falling until I want it to until I want it to drop, and it just sits there until we get things aligned. Now, looking closer at the bar itself, you'll see some numbers on the bar, and it goes from 0 to 100. You might think that's marked in inches, but it's not. It's marked in percentage. So whatever length of bar you use, and you don't have to use these longer ones. You can use a little bit shorter bars if you're setting up a shorter system. But these are marked off in percentages, and there are calculators online that show you where to attach the wire to the drop wire when you do tapered cuts. When we're doing equal span cores, then both wires will drop from the same one. They'll both be out here at 100. But if you have an unequal cord, like a tapered core, then one is going to have to drop faster than the other, which will require that you attach the wire someplace closer down here to the pivot so that it will slow down while the one farther out will be going faster. Now I've got a very simple block of foam out here. This is just going to be an airfoil for a 36-inch span, 6-inch chord, little park flyer. And it's a constant chord cut, so this will be the first one illustrated. We'll get on, of course, to the zero wings later, but this will be the first one just to show you how to do a constant chord. Now we get to the drop wire bow itself. Now my bow is, again, very simple. It's just a piece of very lightweight 1x2 from, again, Home Depot. Let's get up here. Now this is pivoted. I hang this from my ceiling so that it's just hung above my cutting surface. Now before I hung it from the ceiling, I had a bow with a hole drilled right here, and a dowel went through that hole at about a 45-degree angle to a tail wheel assembly, so that the tail wheel supported the bow at approximately the same angle. Now you can see that the 3/8 inch tube here, or not tube, 3/8 inch spring wire. This is spring steel piano wire, and it's 3/8 inch. That passes through holes that are larger than the actual wire. And you can see the wires angled out so that when you attach the spring or the cutting wire down here, as you drive these wires down, they get a little bit further apart out here, and you use that to tension the wire. You need the wire tensioned pretty tightly. I mean, it doesn't have to be like a bowstring, but it's got to be pretty tight. You don't want wire lag. If you get this thing too loose, what tends to happen is that as it pulls through the foam, the center will lag behind both edges, and it just gives you a poor cut. But as long as you keep the wire at the proper temperature and keep it moving, you should be fine. And that brings us to the distances, or the core lengths itself. Some people say that you've got to have, huge lengths here in order to cut big wings. Well, that's just not true. I've cut wings for 3-meter gliders on this, using panels and putting the panels together. What you do not want to do is get a really long bow out here, because there is absolutely no way that you can prevent extreme wire drag and lag, so that as it comes around these the different templates, it's dragging in the middle. So anything here in the middle is going to be dished out as you come around there, and there's just no way around it on long cuts. You can't do that. I never cut. My little bow here, I think, has got about a 20-inch span out here. Let me check it. But I never ever, let's get this up here. Yeah, about a 20.5 inch by the time it's driven out to this extent. This is about 20.5 inch span, and I never cut that wide. I restrict my cuts, or my cores, to about 18 inches. And if you need longer spans, of course you can, the chord hardly matters. You can do some extremely wide chords on here, but the width does matter, so you don't want that dished out effect. And it's very easy. Just cut these in panels and then bond the panels together for any length wing that you want. So don't make a lash up here and use, huge bow lengths, because it's not going to work out for you. All right. Okay, well, I'll pick up the tripod that I accidentally kicked over here to my right, and put this back on the tripod and show you how the setup works for this simple equal chord core cut. Okay, first up, the templates that I use are the ones that I've converted almost all of my stuff to. We showed that earlier. I 3D print these using PETG filament and then put aluminum foil tape, duct tape. You get that again in a big box store. I ought to buy stock in the places, but just a strip of that, and that keeps the hot wire from melting the filament. I've even made these out of PLA, which is not nearly as temperature resistant as PETG, which is what I use now. I mark all of these and keep them. I've got a big box full of templates now. But we designed the template, you remember, with this cutout in front that matches up exactly with the leading edge of the airfoil, and the same on this one. You can see this cutout here on the bottom right here, and what that does is it allows us to take the template, put a straight edge here on the foam block and move that little cut there right up to the very edge of that straight edge, and then start pushing in the nails. I use I think these are 1.5" number 16 brad nails, and don't get anything smooth. You would be tempted to get something shorter, but this foam, and especially since after you take this one out you're going to put another one in the same hole, these longer ones, 1.5", gives a lot more stability, and there you go. So now I can remove the straight edge since we have things lined up, and making sure that the template is in fact down on the surface here of the bed. We want to make sure everything is flat. Go ahead and put in, there we go. Now, all right, now the cutting template, and we always do the bottom first, so the cutting template now is in place. I'm going to do the same for the other side and then get the system set up, get the wires attached to pull through, and show you where to go from here. One thing I wanted to add before we go any further is that this simple wing here does not have any washout at the tip. Washout means that the tip is at a higher, or actually a lower angle of attack than the root. And what that does is it helps to prevent tip stalls on, and we're going to use some washout with the 0 cores, but we're not going to use any washout with this. So the lower templates here are flat on the table. In order to get some washout and change that angle, all you would have to do is, when you put this on, is to raise the back end of the tip template up a bit, and of course you can determine how high this has to come by how many degrees of washout you desire, and you can do all that in your CAD program very precisely, and it will tell you. Usually in a wing like this, if I were doing washout, I would have to take this up about 3 millimeters in order to get 1.5 degrees or 2 degrees of washout. So that would be how you would get washout in a foam core, and we'll address that again when we get to the 0 wings. All right, I've got both lower templates on the block, so now I'm going to set up the cutter and get ready to make the cut, and we'll resume at that point. Okay, we're getting ready to cut here, and let me do a little handheld camera action here if I can do this without wobbling all over the place. There are a number of ways to connect your power supply to your bow, and I find that this is the easiest. I just use alligator clips, and you can connect way up here. Some people, and me myself included, will connect the alligator clips down here to the actual wire itself. And you can do that, and I might do that as an illustration when we do the wings for the Zero. But in a lot of cases, and this is one of them, you can take a look down here and see that there is just not a lot of room here between the upper surface of your template and the bottom of your board here. The reason these are so thin is that I can actually get 2 chords out of this one block. But if you have a huge alligator clip out here on the end, it starts interfering. It rubs against the base. So I use some nylon string and attach it that way. And I use nylon string just about exclusively now, no matter what I'm cutting, because it's just so easy to set up, whether it's a narrow or wider template. But the wires, of course, have got to be connected to a power supply, and that's what we're looking at over here. I think we talked about the power supplies earlier. I'll go ahead and turn this one on. And the power supply is actually controlled by that little dimmer switch there on top. That thing cost about $2, and you can get them on eBay. It's called an LED dimmer. And you can adjust the power output using that. Now, what I do, you don't have to, but if you'll look down here, I've got a foot switch, if you can see it under here. Let me see if I can drag this out. I'm going to have it out here in a minute anyway. I've got wires everywhere. Okay, there's a foot switch. It really helps to have that so that you don't have to worry about handling hot wire. Now, the last thing you can see, I've got stacked up on here a bunch of weight. You don't want this to move. It's imperative. People use bricks. I cast these from old tire weights. I used my wife's old cupcake pan. God, she raised hell about that, but I bought her a new one. I molded these from foam and hydrocal 30 and made my own molds. But whatever you use for weight, whether it's just bricks, a friend of mine uses bricks wrapped in heavy-duty brown paper just to keep them cleaner, and he uses bricks and does fine. But you're going to need heavy weight. This cannot move during this entire process. It's got to be stable. All right, let me put this back over here and see if I'm anywhere reasonably lined up, and we'll do a cut. Now, the lines for this constant chord extend again from the wire around this pulley and around the drop pulley, and as you can see, both of them from both sides, they all come here and drop together, and they're tied out here at the 100% mark. Both of them are at 100%, therefore they will drop the same distance. We're doing a constant chord, so that has to be at 100%. And then, of course, they're just held in here by the bulldog clip. And when I take this off and drop it, then it will pull the wire through the template and we'll be all set. So that's where we're going to go from here. Let's see what we can do next. Okay, everything is tensioned. We are all set up. This had to be tilted just a bit because when you take the wire, take a look at it as it contacts the front of your block, and make sure that the wire enters exactly the same. Make sure it enters on the right and the left hand side at the same time, and you can adjust that very slightly just by tilting the block until you make sure that your wire is contacting the block at the same time on both sides. Okay, and this one is, I moved it a little bit too much there, so I'm going to move it back just a tiny bit. All right, now there's no heat on the wire yet, but I'm about to step on the switch down here, my foot pedal, and keep it down. Now, because this cuts so low, and I have my lines up here pretty high, I'm going to have to use my thumbs to keep this down so that when the wire, hot wire, rides down through here, it remains in contact with the templates. There's a couple of ways you can get around that. Number one, you can, I've got spacers on these because I normally cut thicker stuff. You can take the spacers out. They come out very easily, but I was just too lazy to do it when I can just sit here and hold these down with my thumb. So what we'll do is go ahead and start the cut, and I'll show you how that rides down that wire. Remove the wire so that it's not on your templates and not in the foam. Turn it on until you've got heat, then drop it down and in. Okay, had a short power problem with my power supply, like it wasn't turned on. It works much better when it's turned on. So we're going to try this again. Hold the wire up so that it is not touching the foam or your templates, and just apply heat to the wire. Make sure that it gets up to operating temperature. Then bring it in, pushing it down and into the foam. Okay, and now it's starting to cut, and it will cut at a very even rate, controlled by the weight on your drop bar. And you can see that I'm keeping it pushed down so that it does not ride up on that little very low template. But here it comes right on through nevertheless. And we're getting a nice smooth cut. All right, and it pulls out and it's stopped here. I've got my foot off the power now, so the wire is cool and we're all set. Now that was the first cut. Take the tension off of the strings just by pulling the drop bar up and setting it back in its holder. Then all you have to do is move this stuff back, and we're going to replace these templates now, the bottom cut, with the top cut, and we're going to do the same thing again. Stand by for just a second. If you'll recall, when we made the templates, and regardless of what you make your cutting templates out of, we talked about the positioning of these holes that hold the template to the foam. They have to be exact. All of your templates have to have the holes aligned so that when you make your templates, no matter what you make them of, you keep the holes aligned so that when you pull one off, put the other one on, they go in the exact same spot in the exact same holes. Otherwise your airfoil is going to look rather strange. That's easily accomplished with 3D printed because the computer accuracy and the print accuracy does all that for you. If you're drilling your own out of hand-cut templates, make sure that you've got them all stacked together so that you get the holes exactly in the same spot on all of your guides, because they've got to fit in each other's holes to keep everything aligned. All right, now we have the top template on. We'll go ahead and do the top cut. Let me get my foot ready on the pedal here. And what we're going to do is the exact same thing that we just did for the bottom cut. All right, I'm going to let the drop bar take up the weight. Okay, the weight is on the pull wire now. All right, I move it so that it's not contacting either the templates or the foam, and I turn it on to get the wire up to heat. That way everything is even when you start cutting. All right, drop it down, slide it up, and start it across. And here we go. And once again, I'm going to hold down on the pull cords just to keep it going in the right direction, just so that it doesn't pull up off of that template. And as you can see, it cuts right on through. Now, I made practice cuts in foam to make sure that I had the wire temperature right. That's another thing to do, but that's just obvious. That's so obvious I didn't even cover it. But there you go. Now we've got the top done. So that is a core that's complete. Now I'm going to turn this over and do the same thing. I can get two, it just so happens with this small stuff, I can get two cores out of one set of shucks, and since I'm not going to be bagging these, I can get both of them out. Now if I were bagging these like we're going to do with one of the sets of the zero wings, then I would need one panel in each core because we would want these shucks to help hold things flat when we do a vacuum bag. But there we go. We have now cut that, and I'll take all this apart and show you the wing. Okay, I've pulled the template off the end, and I have not opened it yet, so you're going to see the core the first time I see the core, and let's see what we've got here. Okay, top looks pretty good. Got a nice smooth cut here, a nice smooth surface. The wire did not stop anywhere, which would make indentations in the foam. We turn this over. Okay, we got just a tad of a hesitation in here somewhere, and there is just barely visible, but nothing that would affect the quality of the core. So now you can take a look at the airfoil. Let's see if I can get this focused. You can see that we've got a perfect airfoil. That's one of the benefits of using hot wire cut wings. There is no way you can replicate in a balsa wing with covering the accuracy of these airfoils. Now this is another low Reynolds number airfoil here I really like. It's by Dr. Selig. It's called a Selig 3014, and it's good at low Reynolds numbers. But there's the panel. Works fine. You can see we've got just a little bit of angel hair back here, which means the wire was cutting correctly. Showing a little bit of that angel hair is fine. A lot is not, but there we are. A couple of strokes with a sanding stick will make this leading edge perfect. It's almost perfect right now. So I'm pleased with the way that came out. That would be a successful cut. Now what I'm going to do is, like I said, I'm going to turn this over and cut another one out of the other part of the block, because as you can see, let me move this enough, as you can see here, this only amounted to about half the distance. So if we come down here and do this, we can get another core out of this. So cheapskate that I am, that's what I'm going to do. So there we go. But this is just an example of cutting constant cord. And the next one up will be our zero wing, and I'll show you how to do the calculation. Well, actually, I very seldom calculate, I just eyeball it. But there are online calculators that tell you exactly where to connect each side with what percentage on your drop bar in order to get the distances that you want out here on either end. I've done so many of these. Like I said, I usually just eyeball it and I can get it close the first time, and then I use that close the first time in order to move it and get it perfect. But we'll go into that a little bit later. But that's how you cut a foam core. Okay guys, as you know, obviously, from our drawing and CAD program and cutting the cores and everything else, you know our wings are tapered. And there's a very easy way to figure out exactly where your settings should be on your drop wire cutter. There are a couple of calculator programs out there. The one showing on the screen now is by Neil Gillis from way back when. I've had this program for a long time, and it's extremely simple. I mean, it's just dial in the numbers and poof, there you are. There is yet another one that is it's based on a Microsoft Excel spreadsheet, and it's just as easy to use. You plug in the same numbers and you get the same answer, or you better get the same answer. So let's do that for our zero. Now, my attach points are always going to be 530 millimeters apart. I have found that it's absolutely ridiculous to try to use huge drop wire bows because you get wire lag between the front and the back. As this comes over, it dishes out your airfoils. It looks ridiculous. It's much easier to use an arrow width bow, keep the wire tight, and then bond the cores together to make anything you want. So we'll put the attach points in 530. The cord for the tip we'll put out here, and as you know from CAD program, it's 126 millimeters. Put that in for the tip cord. For the root, we'll come in here and put 230. That's what our root cord was. And our span, of course it's half span for this core, but it's wherever your half span is 397. And there we go. Now if you punch the calculate button, you're going to get 43.9, which is as close to 44 as you can get. So we're going to use 44, and I'll show you how we're going to set that up on the drop bar in just a moment. So again, you get the same thing over here. We'll put in again 530 and 126 and 230. Whoops. 530, 126, here we go, 230. Had clicked the wrong square, and the core span is 397. And as soon as you hit enter, it pops up 43.9%, just as it did on the other one. I'll try to find Neil's little simple PC executable, but I will definitely put a link in to RC Groups for Curtis's, I think this is Curtis Statler's, I believe he's the one that developed it. Anyway, we'll put a link in. But this will tell you how to set up your drop wire so that you can get this tapered cut. You don't have to worry about this just showing a leading edge or anything. It doesn't matter. This one demonstrates exactly what we're going to cut. This one looks odd, but the result is exactly the same. So let's move over to the drop wire cutter now, and I'll show you how it's set up, and we'll go ahead and cut a tapered core. Okay everyone, we're back to the drop wire workbench, and the bow is suspended over the core. And here's the core. The core is going to be moved up until it actually contacts the wire, and we'll start from there. And as you can see, it is actually sitting a bit sideways, and that will not have any effect at all, or the effect is too small to be noticeable. And I'll put the you can see the templates are ready to be attached. Now the template on the tip, and this is a left wing tip. Be sure to make a right and a left wing. I can't tell you how many times I've done that. This just happens to be something that I have. It's a little razor knife holder that I made, but I know that it's 3 millimeters thick. What I'm going to do when I attach the tip out here is, of course, have it aligned with the front of the block as usual, with the front of the core block. And then the back is going to be lifted up off of the table by this 3 millimeter thickness back here, just like that. Just put it under there to hold it up. 3 millimeters right at the back. That will give us, or give me, you might not want to use any washout, but it'll give me what I want as far as washout, about 2 degrees, and that'll be perfect for this aircraft. When we come down here to look at the drop wire itself, again, it's the same setup. The drop wire bar, this 1 inch by 1/4 inch aluminum bar, is marked off in percentages, not in inches, but in percentages. And we have, of course, the full length out here at 100%. Back here, though, when we want to pull down the short side, this one is going to be at 44. See if I can get down here and get focused. Well, I'm not sure that that's focusing, but we'll see. This is 40. This is 50. This says 45, but it's covered up with the string. So this is pulled back to about 44. Now we had 43.9, so that's going to be close enough, and you'll be amazed. It'll be right on. So I'm going to get set up now, and I'll put the camera over here on a mount so that you can see the actual cut, and we'll go ahead and get started cutting this core. Okay, everything is set up. You saw the drop wire settings. The templates have been mounted now. This is, of course, the root, and this is the tip. And over here, let me see if I can bring the camera over without messing everything up. You'll see I put the little 3mm shim under there to lift the trailing edge of the let me move the camera back again one more time. Yeah, to lift the trailing edge of the tip, and that gives you washout, which will help prevent tip stalls. Now, the other thing that you have to compensate for or take into account is that the wire, in order for the calculations to work right, the wire is right at the beginning of the cut now. It is right where it's going to be. So you have to be careful when you apply heat that you don't inadvertently start getting chops and cuts that you don't want, because this has got to start right here in order for the calculations to work. But there's just a little bit of play after I unlatch the drop bar. Now the pressure of the drop bar is on the control strings, and it's ready to go. So what I'm going to do is push this back just a little bit. I don't have a lot of room here, but push it back so that it is not contacting the core. And right now I'm going to start the wire. I've got the wire heat is on with my foot pedal. I'm going to let it heat up and get a nice even heat across. All right, and then down and in, and then let it go, because you've got to let the drop bar determine the speed, not your hand. As you can see, this one is moving much faster than this one. Keep these down so that it doesn't tend to lift up the wire. And there you go. They both came out at exactly the same time. That's what that does is it confirms that you had the correct percentage in your wire. And that's all there is to that. It's pretty easy to do. I'll go ahead and do the top. I'll speed the video up, but I'll go ahead and do the top wire, then we'll take this apart and let you see the core. Okay, everyone, as has happened so often in our journey with these little models, I've gone over time. I really don't want to make this so much over an hour as it has gone, but we've made a lot of progress, and we'll have to wait until next time to actually do some vacuum bagging. Sorry about that, but the next episode, that's what we will do. We've got all of our sanding done now on the fuselages. We've got the wing cores cut, and there is one thing that it's sort of a tradition among builders, is after you get your model to a certain stage in the building process, you can do a bench flight. That's right. You can assemble what you've got going on the bench and make it look like an airplane. So let's try to do that right here. Okay, let's get this out of the. All right. Well, what we have here is something that's starting to look like a zero. All right. We have the tail pinned on, the vertical and horizontal stabilizers, and the wings on with the little braces for dihedrals. That's called a bench flight. Now, it's actually bad form to actually make the gun sounds at this point. You can't go rat-a-tat-tat until the wings are attached to the fuselage and you can actually hold the model up. Then you can go rat-a-tat-tat. But here is bench flight number 1, and we will probably get a couple of more of these bench flights in before we get the actual flight. Now you can also see out here on the wing tips, the tips have not been added yet, and they will be added and shaped, and they will be on there when we get ready to start doing the bagging and get it all fiberglassed. Of course, the one that we're going to do in fiberglass. The other one we're going to do in paper covered. Okay. All right, so again, sorry for the delay and sorry for taking so much time, and if your expectations were that we were going to be able to do some bagging today, I apologize, but we will get to it next time. So thank you for hanging in there this far.